So we're dealing with percentages in this booklet, and we're going to focus on the sections highlighted in yellow. The first section here is just talking about converting from percent to decimal and potentially vice versa. So as per usual with this booklet, for those of you that have given me feedback about it, you mentioned it's pretty easy to read. So basically, if you were to follow along in the text here, what I'm going to say to you in terms of doing the examples is very similar to what's being talked about in the book. There's a few examples here that you could look at as well involving conversions. So instead of actually going through these examples, I've chosen to do the exercises as you see highlighted in blue. We're going to do a healthy amount of them, and I've left some of them empty for you to try on your own. So we're doing about, I don't know, maybe 60%, pardon the pun, 60% of the questions here. If you calculate it exactly, that's an estimate. There you go. Anyway, write the following decimals as percentages. So I want you to try to do any question that has a decimal already. The goal here is to not use your calculator. So don't pick up your calculator. You need to do these in your head, or at least try to do them in your head. So 0.31, can someone tell the chat there, or type in the chat, what is that as a percent? So that answer is 31%. So how do you go from decimal to percent? How do you go from decimal to percent? What do you multiply by? Yeah, you multiply by 100. You multiply by 100. The reason is the word percent comes from the French and it means literally out of 100. So percent is literally a French, it's a compound word in French, sorry, from the French, and it means out of 100. So anything that involves a percent, you multiply by 100, and what that means with a decimal is just move the decimal a couple of times. So for all of these guys here, just move the decimal a couple of times to the right. So if you do that one there, you're going to get 67.4%. Okay, any volunteers on this one? Thank you, Nicolas. So we're going to move that decimal over. Oh, look at that. It's more than 100. It's more than 100. But that's okay. See, you can have a percent that's more than 100. That just means that it's growing. That whatever the 189% is describing is growth. Whenever your percent is less than 100, it refers to a decay or something that's decreasing, or a fraction less than 1 of the original quantity. This is more realistic for everyday life. Yeah, that is. Yeah, let's keep it to 3 significant digits. So Huria is answer, just keep the 7 there as well if you don't mind. But that's cool. Yeah, we're gonna move that decimal over. Boom, boom, 1, 2 spots, and there it is, 5.7. As you see though, with your assignments so far that I've been grading them, I'm very gentle when it comes to the precision and accuracy. So like if this, I don't mark every single question the exact same way. Like questions that are way harder, I'm more lenient about stuff like this. Questions that are, if the question is about doing the actual rounding process, then the marking is more strict because that's the focus of the question. So the focus of this question is somewhat heavy on the rounding as well because we're just manipulating a number. We're not doing any application here. We're just manipulating numbers. So we're getting into some annoying ones now, 3/8 and 13/19. Before we do these ones, you can certainly see that these ones here as well, which you're going to try on your own, just move the decimal a couple of times, okay? So let's talk about this one. Tamerlan, you're right on point, my friend. So yeah, first things first is 3/8. 3/8 is a number that you should know how to do in your head, especially if you're coming from trades or anything like that. But let's say you don't, that's fine. So just grab your calculator and do it, or use long division. And of course, that is the correct answer. So I'll just do this, a couple of hops there. and get 37.5%. Yep, that's good. Oh, thank you. I was getting confused for a second there. I was seeing 3 different answers, and I know there was just self-correcting or whatever. Sorry, I'm gonna change the thickness of this pencil here. It's a little bit too thick. Anyway, 13/19. Now, this one here, oh no, I lost my calculator. Do not type it in the chat. Do not type the answer in the chat. Let's figure it out together as if we were under some severe constraints without a calculator. So if you had to do this by hand without a calculator, you're going to unfortunately have to do this. Now, I'm not doing these ones here, so just ignore these. So we're going to do long division. Yeah, your math teacher's doing long division at 9 in the morning. So we're going to do 19 into 13 point blah, blah, blah. I'll put lots of zeros here. So if you have to do this by hand, yeah, you're going to have to dust off your calculator. No, I didn't want to know the answer. Oh, no. Now I'm cheating. No cheating. Anyway, 19 into 1. No, it's okay. I'm just joking. It's okay. I don't care if you type the answer, and I just don't want to cheat myself because now I'm going to peek over there. So you've made me what do you call it? What do you call it? What's the word? I'm curious to see the answer now. Anyway, can someone confirm 114? Again, no calculator. Just try to do this in your head. Hopefully I don't screw this up. So we have 160 there. 19 into 160 is 8. Is 8 times 20 is 160. Yeah, you could do that. You could do 3/8 times 100 over 1. That's actually a good idea. Yeah, if you want to work with fractions first, absolutely. Can someone confirm the 114 here? Because I'm not using a calculator and I'm not doing it in my head either. Yeah, you could do that. You're still going to have to get 3 decimals, so it's going to be annoying. But yeah, you can do it. Yeah, absolutely. Okay, I'm still going here. I'm doing long division. This is hilarious. The only issue really with me is this pencil that I'm using. It's so slow to use. What do I divide 19 to see? What I do, yes, of course, yeah. Yeah, exactly. So like, I'm gonna do this 2 different ways. So just bear with me, everybody. Let me do it the long way here, which is really frustrating. I get you. So thank you for your patience. Now I should keep on going, but I know that 4 is gonna be like that's gonna be a 2 there. So anyway, bottom line is this is 68.4. So what Huria is saying is, and Nicholas, your comment is very good as well. What I'm going to go with Huria for a second here, just to point out something. Their argument is this, okay? 19 to go to 100 is approximately, okay? Not exactly. It's approximately 5 point something. So if I take 13 and I multiply by 5 point something, 13 times 5 is 65. So this is my estimate. My estimate is 65%. And then my exact answer is 68.4. This stuff in blue here is not something that I can train you individually because not everybody thinks it the same way. So, for example, in the comments that you're seeing from your classmates just at the bottom there, that this estimating explanation falls very much in line with their thinking in terms of fractions and manipulation and estimating common denominators or such. It's a great thing to do, and that's a very powerful thing to do. But if you don't see this, then that's okay. An alternative, you could take the 13 and the 19, and let's say you wanted an estimate, make it cheaper. Make it 12 out of 20. Sorry, make it 12 out of 18 or 14 out of 20. If you did 12 out of 18, you get 66%. And if you did 14 out of 20, you get 70. So I know the answer is between 66 and 70. So that's actually how I would do it in my head. I mean, everybody thinks of it differently. That's okay. But anyway, this thing here that I'm showing you here, you're not going to have to do this on a test because, of course, on a test, you're allowed to use your calculator. So hopefully you had a fun time with me talking about estimating there a little bit. Like I said, I didn't want to do the second section as a section. I just wanted to incorporate it just on the fly as we're doing examples. So let's keep on going here with decimals. So when you want to go from percent to decimal, we said the other way you multiply, if you go this way, you're going to divide by 100. So dividing by 100 results in the decimal going the other way. So what's the percent as a decimal here for A? What would be the answer? Yep. And over here, what would be the answer for 112%? Yeah, that's 1.12. Let me know in the chat, people. How you doing here? Are you happy with the pace here? Am I going too slow? You know, what's going on here? Too fast? Okay. All right. Oh, fractions. So this is the kind of thing that you traditionally might see in finance. That's correct, Sanjit. Yeah. So this is something traditionally that you might see in finance. My suggestion is to first write the fraction as a decimal. So half is 0.5. So then you have 13.5. Oh, good morning, Sanjit, to you too. So if we did that there, then it's easy to convert, which is exactly what Sanjit has in the chat there. It's not so slow today when I'm writing the what do you call it, the stylus thing here. Usually it's so slow. I guess there it is. I can't even draw a circle there. It lags a little bit. Anyway, 1/4 is 0.25. So here's a little bit of a nasty one. So yeah, that's right, Matthew. Just you missed the 2 there, I think. Just stick the 2 in there. 1, 2. So the decimal is going to go right there. So notice what I do. I mean, you do not have to be this picky as me. You do not have to be as picky as me, okay? But by me being so like strict about lining things up, see how I'm like writing it like as if I'm writing a computer program. If I line it up nicely and pretty like that, then you will not mess things up. Or because I don't want to put a dot there because then it just looks confusing to the eye. But anyway, hopefully hopefully that kind of jogged your memory. And like some people were mentioning at the beginning, they might be a little bit tired. I can respect that. Um, hopefully we didn't start off with anything too dangerous. So we're gonna just keep on chugging along here. So here's a couple questions involving just calculations with words. So how about I give you a minute and I want you to think about what the answer is here. Type your answer in the chat. Let's see if we can get some good numbers in the chat there. And then I'll answer the question and I'll just wait for 1 minute. Okay. I see some 85s there. That's good. Sheldon, make sure you put the units, but you're looking good, I think. I agree. I think the answer is 85. Let's try this out today. I think Marco, you might have hit 19 on your calculator by accident. Did you do 16 out of 19 by accident maybe? Or I don't know. Should be 85. I'm gonna just write this one out with my keyboard this time. So we know that 3 liters short of being filled is equivalent to saying that 17 liters are left in the container. So that's equivalent, okay? When you see something, now you might be like, why is this guy writing English stuff here? I'm just keep in mind, some people may not be able to read it as fast as you because they haven't studied math and English as their first language. I was actually having a conversation about this with one of my students from the degree program, who's a trained mathematician, but really says that there's a little bit of a barrier with the language, but the math part's okay, but the language part's a little bit thing. So I do take my time for those reasons because there are some very smart people here that, of course, maybe are not as strong in terms of reading in English, which means this is an opportunity to learn how to communicate a little better. So anyway, 17 liters out of 20 liters. 17 out of 20. Okay? So that's 85%. So it's about reading the question. So reading the question here, it says, the container can hold 20 liters. So that means the container is 20 liters. So it's missing. Thank you, Sanjit. I'll put that in there as well. It's 20 liters capacity, but missing 3 liters. Yeah, I like that. I like the way of saying that, Sanjit. So thank you for that. I was just saying the thing in quote, it just translates that way. I was trying to figure out why 86.9 was in the comments there. I was trying to think of what fractions. It was either 19, either 17 or 23 or something like that, or 19. Anyway, let's try another one. Let's try another one here. If 5 cubic yards of sand are mixed with 8 cubic yards of topsoil, what is the percent mixture? Sorry, what percent of this mixture is sand? So let's do this, okay? What's the total? The total is 5 cubic yards plus 8 cubic yards, which is 13 cubic yards. And the amount of sand is 5 cubic yards. The real importance here in these questions is that you identify the units. So yeah, the answer is gonna, sorry, 13. That's 13. My apologies. That's 13. I just added it wrong quickly in my head there. Okay, so we have the percentage of sand, okay? So the sand as a percent, here we go. So sand is gonna be 5 cubic yards divided by 13 cubic yards, which is equal to 5 over 13. And it doesn't say any precision here, so I'm just going to go with the nearest percent. So this is approximately 0.38, which everybody at the beginning was throwing the right answers for those percentage conversions. So there you have it. So anyway, you know, sometimes when people write a formula with percentages, they'll do this. They'll put this in the formula, times 100%. Who's ever seen a formula where they do this, times 100%? I've encountered several over the years, but you know, you see formulas where they do that. Yeah, percent error is an example. This thing here, it literally means times 1. So you know, 100% means 1. So that's why sometimes people like to write this in a formula, and sometimes people don't write it at all because you don't really need it. Let me explain to you what I'm saying below. Because you could answer this question a little bit. You can answer this question with that style. So I'm gonna just copy what I'm saying here so I can explain it faster. So if we copy that here, yeah, because it confuses people because you do the 100% on the calculator. I don't like it. So some people will do this, which for me is absurd. It is absurd because you don't need it because it's just 1. Whoops. So I don't want to do that. We're going to keep it so straightforward. We're just going to say multiply by 100 because this thing here, everybody should be strong at doing. You don't need someone to tell you this. You can do it yourself, okay? Sorry, a little bit of a speech there. Let's go to page 5. There's a table at the bottom of page 5. So this is page 5 in the notes. And again, I'll post this booklet on Blackboard. As you saw with the other booklets, whenever I highlight something in yellow or a big fancy color like that, it's something usually that I'm trying to emphasize for you to either be familiar with by memory or just be able to recognize its importance. So these are percentages and fractions that you should know how to do quickly in your head. Like there's no negotiation really for the first 3. You should know quarter. Most people won't have issues there. Same with the tenth. A tenth and a hundredth and perhaps a thousandth. Thirds and 2/3 are pretty strong. The fifths usually are not as quick for some people. But anyway, this table in yellow is kind of like the bare minimum of percentages that you should just be able to recite from memory. And if you don't see them from memory, you should at least be able to look at an answer and decide whether the answer is reliable enough that like you can compare it to something. How kind of I did earlier where I compared it for the question where I did long division. Anyway, this lesson, there really is two big objectives. The first of this thing here that we're doing is kind of warm-up stuff. All the stuff we're doing up to this point, in my opinion, is really just warm-ups. The big objectives are section 4.2 and 4.4. So 4.2 is percent statement problems. And then 4.4 is where we start talking about increasing and decreasing. And we'll do that one after the break. So let's take the rest of the first half of today and talk about this type of thing. So we're looking for questions like this, and I'll just kind of highlight something here so that you have an idea. Like, look at this question here. What is 20% of 600? That's a very typical type of question. We're going to talk about how you can set up questions three different ways. There's three different possible real ways of writing this, and I'll show you here because they're very nicely cataloged on pages 7, 8, and 9. So the first type of percentage quantity question or percentage statement problem is this. It's where you want to find the percentage of something that you know. So I'll just highlight the actual statement there. 30% of 180 is what number? This is the kind of question that is really important for you to be able to do. And thank you very much, Sanjit. I'm gonna actually do a little bit of surgery here on the book. So I'm going to take this thing here and highlight it and just put it aside for a second. That's one type of problem that we're going to deal with. The second type of problem is this one here, which is kind of working it backwards. This is the one that is also, I think the first one I said and this one are very common because this is the one that you do when you get your test. Please do not get 54 out of 180 on a test ever, but I'm just saying, like, that's how you would calculate a test score. You take the smaller number divided by the bigger number and just say, oh yeah, that's my score. That's something that you've done hundreds of times, I'm pretty sure, over your academic career. And then finally, this third one, which is kind of like the funny looking one. The wording is a little bit weird. I've highlighted these three ones because I'm going to actually do them right now on a separate slide. So I'm doing this a little bit different than what you would have seen in terms of the author's comments. We're saying the same thing. I'm just trying to show you them all on one page. So there's the first one, there's the second one, and there's the third one. So all those three pages that I skipped over that you can read the examples as well on your own, same answers. I'm going to show you how I approach this, okay? And I think that you'll appreciate the way that I'm showing you because it's all on one page at least. In mathematics, the word is and the word of are very special in terms of what they represent in terms of a symbol. Can someone tell me what mathematical operation the word of is represented by? Of? Does of represent add, subtract, multiply, divide, square root? What does of represent in mathematics? Does anybody have a thought there? So the operation is multiply. See, okay, did you notice Sanjit's answer? Who agrees with Sanjit's answer? Who agrees with Sanjit's answer? I'm not saying it's right or wrong yet. I'm not saying if it's right or wrong yet. But who agrees with Sanjit's answer up there? Okay, good. So did you notice that Sanjit used multiply? That's good. I'm seeing a lot of agreeers now. Okay, so Sanjit's answer implicitly, he wrote multiply. So multiply is the word of. What symbol in mathematics would be a nice symbol to represent the word is? So what symbol? That's right, Huria. Very nice. Now watch what I'm going to do. If I change those words into symbols now, I'm going to write the following statement right underneath. And this time you'll always knock it out of the park. 30% of, sorry, you got to convert that to an equation mode. 30% times 180 equals question mark. Did you see what I just did? It turned it into a mathematical statement. And this is the nicest mathematical statement too. Why is this one nice? Because all the numbers are on the left-hand side, so it's already isolated. Bye-bye happy face. So this is going to be that the question mark that we're solving for. I don't want to use a variable here. I'm not using a variable. I just want you to see it very simple like that, okay? Perfect. So thank you, Huria, and thank you, Sanjit, earlier for the correct statement. Now, can I, if you don't mind, everybody, see this time symbol? Thank you, Cosmo. See this time symbol? I'm going to put a dot there, okay? Instead of writing times, I'll write a dot. Hopefully that doesn't bother anybody. And instead of writing question mark, I'm going to put X. So X here just means variable. It does not mean multiply. And I think you'll understand why I'm doing that. I want to turn it into an algebra question. I'm not trying to scare the crap out of anybody here, because we will do a lot of algebra later in the course. But this is really, like, for me, the safest way to explain it to somebody is to just turn it into a statement with algebra. Now that you've seen that, every question that we do thus far really fit. Sorry, the questions that we saw thus far in terms of the three types of problems with percentages, you don't have to see them anymore as three types of problems. What you do is you just read the words in English and turn them into symbols. Watch how easy this next one is. So what is the word what? The word what, we'll call it X because we don't know what it is. And don't worry about percent. Ignore the percent there because we can make a percent ourselves later. What does the word of represent? We said earlier, right? It's multiply. So I'll put a dot there, which means multiply, but I'm not going to put that big chunky X symbol there because it looks like X. Then we just write 180. What symbol is represented by the word is? So Huria got that one before. That was a equal sign. So is equals. And Sanjit forgot to hit shift on the keyboard. That's okay. And then we have 54. So there you go. You can see that we can write it as a mathematical statement and just divide both sides by 54 by 180. Divide. I can't type today. Both sides by 180. This is the most simple algebra question. I mean, I'm not going to ask anything this dangerous, at least until the last part of the semester. Can someone do that on their calculator? Just give us a percent for that. That's fine. Actually, give me a decimal for that, please. Let's go with two decimal places. Sorry, yeah. 0.3, 0.3. Oh, nice. Nice. That's always nice. You had to round that, right? This one did it work out nicely or no? Was it exactly 0.30? I think it is, right? Yeah. It looks like it is. Yeah. Okay, Alexandria, on your calculator. No. Your calculator, just type, there's a button somewhere on your calculator that says ABC. Find it. ABC, something like that, maybe. Just hit that button. Yeah. No, not abs. ABC. Or it might be, just a second. I'll grab my calculator. Yeah, thank you, Huria. It could also be a button called change. There's a bunch of buttons anyway. Alexandria, I'll tell you how to change the setting at the end of class if that's okay. Okay, but you know, here actually a comment to you. if your calculator, if anybody in the class gets their calculator and it says like what Alexandria says, like does it say 3/10 or something? Or something like that? I don't know. If your calculator ever does that, there's a button. You could have a button on it called the change button. It looks like a circle almost. But if you really get pissed off, just do this. Just multiply by 1.00. Watch this. Multiply by 1 point, and then just put a lot of zeros and a 1. If you do that, it's going to trick the calculator into making it approximate, and then at least on your screen you'll see decimals. That's what I do if I'm in a pinch and I don't let's say I'm using someone else's calculator and I'm not familiar with the features of it. But yeah, that's the cheap thing I do. Anyway, we'll move on to the last type of question, which is really just a shuffling again. So we have 30% of, so of is multiply. What number? Sorry. What number? That we call that x is 54. Convert the 30% into a decimal. That multiplies by the x. And then divide both sides by 0.30. So dividing by 0.30 gives us what value? 180. So it's actually just the previous question scrambled around. Well, in reality, all three questions are the same question. What you noticed here is that the author of the book, and in terms of my decision to use it as well, this percent statement is just the exact same mathematical quantities multiplied and divided, etc., just scrambled around. I think it's actually kind of entertaining to see three questions that actually end up being equivalently mathematical statements that involve percentages. So that's great. Anyway, let's do some questions. You solved it using proportion. Temerlan, that's the way to do it, my friend. I love your style. So can I write on the screen here? I'm gonna show what Temerlan did. I'm gonna guess what Temerlan did, okay? I'm gonna say that Temerlan did 30 over 100. Oh, is 54 over question mark. Did you do something like that? Was that kind of what you did? Or am I way off? Okay, so I'm not gonna, you can solve this by cross multiplying. So I'm gonna take this though, because this is not the way that I'll do it in class, because it's pretty slick, and not everybody will be able to see it the same way. I'm just gonna kind of gray it out, but that's a very nice way of doing it. You can cross multiply here. Oh God. I would actually reduce it and cross multiply first. So I would do, I would take this and make it 3/10 because nobody has time for big numbers. So we would have here 3x equals, oh, come on. It doesn't like me today, the keyboard. 3x is 540, so x equals 180. So that's what Tamerlan was basically doing. I don't want to presume too much about your technique, but the first step we agreed on is what you were considering. So that's cool. If you did that there, that's beautiful. But like I said, it's not going to be the way I'll be answering most questions because proportions is a topic we're going to cover later. And we got stuff to do here. So if you look on page, let's see here, page 10 and onward, page 10, 11, 12, you'll see a whole chunk of questions, okay? My advice to you is that you should be practicing questions for these, as many as you can. There's a whole chunk of them. I counted 22 in total. So what I've done here is I've selected, let's see here, 6. I've selected 6 questions, okay? So let's do 6 questions. Hopefully we can get them done in the next 20 minutes so that we can be on the correct pace and be ready for a break. So for the most part, the first 4 questions that we're doing are just more straightforward, kind of like reading the words, is, of, if you can, whatever. I'll start with number 5. I like 5. 5 is the easiest one on the screen, I think. So what would be how would you set up an equation for 5? What percent is 48 of 2100? So what is a question mark? Is equals 48. Okay, so this question actually is a little bit confusing. We can't use the word of literally because the wording is so off here. So what I showed you here might be a little bit of these ones are written a lot more straightforward, where they're just literally reading off the words and changing the symbols. This question here, it looks more like something that you have to reword yourself. So I would reword the question like this. I would try to reword the question in a way that we can process it better. I'd say 48 is what percent of 2100? That's how I would approach that. Anyway, if we continue on this path, we get 48 is equal to x times 2100. So my apologies, I don't want you to think that it's all like literal in terms of like this one here, the wording of it is just kind of backwards. But it reminds you hopefully of something like calculating a test score as a percent. If we divide both sides by 2100, then we get what? What is the answer to this question? Any volunteers on that? Thank you, Matthew. We'll go with 229, and we'll get 2.29%. I just did 3 significant digits here because I didn't really read the top part if how many significant digits were asked for. So in the original page it says here, let's see here, 3 significant digits. Yeah, so every answer that we get will be 3 significant digits for accuracy. I promise you that when I give questions on tests and assignments, I'm not going to do this kind of twisting of the words. This twisting of the words to people that are have English as their first language, they're able to flip the words around and get the meaning better. But for other people that may have not learned English as their first language, necessarily this might be a little bit weird to read it how it's twisted. So I promise you that on any evaluations that you get with me, I'm not going to do this unorthodox kind of wording. I'm going to do it a lot more straightforward in terms of writing the question. So I just want to put that out there. So if anybody got annoyed by question 5, I don't ask questions worded like that. Even though the wording, there's not a lot of words here. I try to word it in a lot more linear way, not like kind of backwards like that. So let's go back to question 3 and do something a little bit more, hopefully easy in terms of the wording. So it says here, what is the amount of interest earned on $3,500 invested for 1 year at that percentage rate? So now we're talking a little bit better about things. Talking a little bit better here. So when you want to calculate return on investment, your return on investment is equal to the percent times your initial amount. If you're like, I don't know how to, I didn't know that formula, or I didn't know I could do that or whatever. Again, I'm not going to be giving you finance questions on a test. So if this thing here is a little bit off, just more so and try to think of these questions as me trying to give you exposure to different areas of life that you would see percentages outside of just calculating a test score. So in this case, the return is going to be, let's see here, is going to be 4.25% times $3,500 but 4.25%, can someone give me that as a decimal? What's 4.25% as a decimal? Any volunteers there? Or are you thinking about a break already? Let's see. Yeah. Cameron, you're gonna make it smaller, right? You're gonna make it smaller. So the decimal has to move in a way that it gets smaller. So the other way, okay? Thank you everybody for your effort here. I appreciate it. So yeah, when you turn 4.25% and you want to make it a decimal, you got to move the decimal the other way to make it smaller. So if you can multiply that out, I'll grab my calculator now because these are getting a little bit exciting. I got 148.75. When it comes to money, we're going to go with 2 decimals unless otherwise specified. Let's try a couple more here on this page at least. 38% of a certain job costs this. Then what is the total job cost? So this is a little bit in line more with the orthodox kind of question that I started you off with, those 3 calculations. I haven't got that far yet. Let me take a look here. So 38% of, no, it's all good. 38% of a certain job costs $214. So 38% of a job costs $214 and change, of course. So I think that's how you would solve that. So the word cost here, it could be replaced with the word equal with symbol equals as well. So 0.38x equals 214. Whoops, my finger was shifted on the keyboard there. So x equals, I guess I'm typing it this way, 214.56 divided by 0.38. Can someone give me a number on that, please? How's everybody doing? It's not as chatty today. What's going on? Are you writing a test today or something, or is it just that kind of a day? Oh, thank you, Ria. Why is everybody so quiet today? It's unusual. Today's a sleepy day. Come on. 564. Not you. I'm talking to my calculator, by the way. It's one of those days, eh? All right. I feel ya. I won't pick on you too much today. Don't worry. Hopefully the stuff that we're doing today is not as annoying as last week. That calculator stuff probably was annoying for some people. Anyway, I'm going to scroll this down here to question number 11. So that was 4. I'll just kind of leave it like that so you can hopefully read it still. Okay, a company produces this many items and finds that 2,000 or so of them are defective. What percent were not defective? So we're going to do the following. I'm going to do this one. I like to write the answers differently just so that, it kind of fits better for each different kind of style, because some people don't want to see algebra. Some people just want to see the calculation. So let me show you a way that I would do this one with less x's, okay? So I'm going to say here number that are not defective, I can spell, divided by total number. So how many were not defective? Think carefully. How many were not defective? At least tell me the calculation. Very good, Sanjit. I didn't check your numbers. I just saw that you wrote an answer that was in the right area code. So 38,950 subtract 2135. I'm assuming that Sanjit's answer is correct. Can someone confirm the number, please? So let's just make sure. Thank you, Joseph. And here we go, 36,815. All right, I need that as I need that to the nearest tenth of a percent. So let's get 3 decimal places. I need 3 decimal places. I need 3 decimal places here. Okay. So what do we have? Thank you. 0.945. Thank you. Oh, I put 2 decimals in there. I invented math. Look at that. So that's 94.5%. Anyway, that was exciting. I'm gonna give you a break soon, I promise. But let's just try to hammer out one more question. Maybe there's 2 more on this next page. I see a lot of words. I see a lot of words. Hopefully they're not disgusting. But we'll take a look. I just made the font bigger, so for those of you that just want to read it a little bit extra there, you're more than welcome to. I think we're gonna just do 16, I think, and then we'll take a break after 16. I like this question because it involves something that you're familiar with, at least in Toronto, is the land transfer tax. And let's take a look what it says. I'm just gonna let you read it on your own first. Okay. So what it's saying is that the land transfer tax behaves like this. If you make a sale or purchase something in terms of real estate, anything under $260,000 of that sale is gonna be subject to a 1.25% tax. So in other words, for every 100,000, you're gonna pay about $1,000 roughly in tax. But then anything over the 260, so if your property is over 260,000 that you're buying and selling or whatever, then that over 260 amount will be subject to 0.75%. So question A here, I'll just mention question A. I'm not going to answer question A. I'm going to do actually question B. But just for question A, I'll make a note here. Since 180 is less than 260,000, you only need to apply the 1.25%. Okay. So since I started it, I'll just finish that. So the answer to part A is simply exactly, I think, what Huria has there in the chat. I'm gonna just see what happens here. We have 180,000 times 0.0125. Remember, 1.25%, I'm writing it as a decimal below. And I'm gonna check it on my calculator as well, because this one looks really stupid. And that's correct, Huria. Thank you so much, eh? That's very good work. Very solid work. Anybody in the class has any background in real estate, you're very familiar with land transfer tax and discussing it in terms of with clients or something, or as a client when you've bought or sold a property. Now we'll do B. So I'm just going to do B here, and then I'll forget about C. So we'll just do B right now.
Sir,
Yes.
where did you
What's
get
up,
1.25%?
I got the 1.25% right here. So anything that's under 260,000 is going to be that. But if you convert 1.25% to a decimal, you get, to a decimal percent, you get that. Sounds good?
On my calculator, I got 0.25. Would you just leave the whole number and then you put the 1?
Yeah, exactly. Yeah.
Okay. Oh, so I did it right.
Yeah, you did it right.
Okay, thanks, sir.
You're welcome. When I did these earlier, I just when I was doing those conversions earlier, let me see here. I'm trying to find it. Just a second, guys. Right here. Right here. See 13.5%? I just did the 0.5% as 0.5, and then I wrote the 13 later. And over here, the quarter, I did the quarter part first as 0.25, and then I just stuck the 7 in front later. But if you're doing it on your calculator, yeah, convert to a decimal and then add the whole part, is what Cosimo's saying, which is cool. So let's go back here and hammer out this question. So we got 400,000. So we're going to say here that the first 260,000 is subject to how much? 1.25%. Is it 30? Is it 3,000, Maria, maybe? I think you mean 3,000. Am I mistaken there? All good. Okay, so there's my commentary on this question. So this 400,000, so we're not doing C. I'm just going to cross C out so you don't think we're doing C. So the first 260,000 is going to get hit by 1.25%. So let's answer that part first. So that's 260,000 times 0. Oh, come on. I'm using the keyboard, not the math mode. 0.0125. Can someone give me an answer on that, please? Don't mind. Thank you. Who has a number there? 3250. Thank you, Sheldon. Okay, so that's 3250. And Huria, thank you.
Sir,
Okay, yes.
how come you have the decimal? How come you have two zeros, 0.0125?
Because you move the decimal is on the 1, right? Two spots. There's going to be a 0 here. When you move the decimal over, it's going to go 2 times, and the 0 will be here. And then the point will be here. So if we do the next one here, then we have 140,000. And then you're going to have 0.0075 when you move the decimal over. Any takers on that one? Anybody have a number there? Yeah, thank you, Tamerlan. Thank you. Thank you, Marco. So that's 1,050. Now we have the two pieces, and we just add them up. So 3250 plus 1050. Okay, James, because 0.75 is a percent. The percent here, you need to turn it into a decimal. So that's why it becomes this. So you need to divide 0.75 by 100. Oh, no worries. No worries. My pleasure. So that's going to be final answer, 4,300. Can someone confirm? 4,300. Yes, I know how to add, but it's Wednesday morning, right? I'm just bugging you. Anyway, thank you, Matthew. Just trying to keep you engaged in the conversation. Anyway, let's take a break, guys. Take a break until 10:15. Okay, I'll give you a little bit. Actually, yeah, 10:15. That's fine. Break until 10:15. No problem. After the break, we're going to do percent increase and decrease questions. We'll spend about I don't know, about half an hour with that kind of stuff, and then that leaves us with about 15 minutes at the end. That if people have questions about the assignment or whatever, they can ask me then. So we're talking about questions involving percent increase and percent decrease. And the first type of question here is where you're actually just calculating the percent increase according to a formula which you can find in the book, but also you can use your common sense too. So Norris, Matthew, and Marco, all of your numbers are looking good because they're all right. Just Norris and Marco need to convert it to a percent, that's all. So in this case, it says here, what is the percent increase for a stock that goes from 437 to 1575? If we apply the formula as you see it, then what you want to do is get the actual increase. So the actual increase is equal to the change, which in this case is, let's do that like this. We'll say that the actual increase is equal to 1575 minus $4.37. Can someone give me a number on that, please? I got 1138. Can someone confirm 1138? I'm not using a calculator right now, so I'm relying on you for help with that. Okay, cool. And then the original starting amount is 437. So this stock here has grown a lot. It's actually more than the growth of it has more than tripled. See, look at that. You've gone from 4 to 15. So that is an enormous amount. But when you're doing a conversion as a percent, I believe it's going to be 260% because it's asking for the increase. So what Marco and Matthew and Norris have written is showing the relative change between the initial and the final. But we're just talking about how much it increased by. So it actually increased by 1138. So that's what we're talking about here, is the increase. So if you divide those numbers out, then you're going to get, I believe it's 260%. 2.60 or 260%. So you notice that the answers in the chat were off by 1 because those numbers represent the percent overall. This is just the change, okay? So when we're talking about increasing, we're just talking about the actual change. So we're measuring the change here. I'll just say we're dealing only with the change. So hopefully that makes it clear to you that instinctively it's going to be different. That's okay. Anyway, are there any questions about that one? Do you need clarification about what just happened there? Why the answer is not 360 and it's 260? Okay. Okay, that's fine. That's fine. All right, so for the next one here, it's actually decreased. So in this case, it's actually decreased. This time, the amount has decreased. So there's a formula for that too. Percent decrease is the actual decrease. Well, let me just write that in equation mode. Over the original amount. I'll catch up to you on that one. 28.8% is correct, I believe. I just checked the answer key. So in this case, you're going to have, let's see here. The amount decreased is 18.46 pounds minus 1315 pounds, which is equal to, help me out here, 5.31 pounds. So then the answer is going to equal 5.31 divided by 18.46. I'm just checking on my calculator. Yeah, I got the same. Thanks, Norris, Matthew, Marco, thank you very much. I got 0.288 or 28.8%. So I've just highlighted the two versions here in yellow. In the book, they don't give a formula for decrease. So I'm just writing the formula here in the exercises so that you have it handy. So anyway, those questions are really just kind of like the starting point. But then we start to get into questions that are a little bit weirder, involving actual applying percent increase and percent decrease. So we might actually skip 7 for a second, and I'm gonna go to questions 8 and 9 because they're actually more meaningful to start with. When I put together the set of questions, I just put them in the order of the book, but I think it's actually better if we go to question 8 and 9 first. So questions 8 and 9 talk about adding 24% to a quantity or taking away 18% from a quantity. So this is the other type of percent increase or decrease problem. This is where you're applying a percent to a quantity. So applying a percent increase to a quantity. And then further down here, we're going to apply a percent decrease to a quantity. So there's two different ways at least of doing this. So I'm gonna show you two ways of doing it. So this is a skill that definitely deserves something to refer back to. So when I highlight something in yellow, it means it's a method or a skill that you should be taking notes on. So in this case, we're adding 294% to that. So what we're doing is we're going to increase 250 kilopascal by 24%. That's what we're saying here. So when it's something, you get something like add 24%, we're just increasing it. The wording is a little bit frustrating, but that's what it's saying there, okay? So method one is like this. Do 0.24 times 250. What's 0.24 times 250? Let's take a look. That's 60. And then add it back. So we do 250 plus 60, and you get Marco's answer. Let me know in the chat. Are you a method 1 person? Who did it with method 1? I haven't shown method 2 yet, but who answered it with method 1? Cool, cool, cool. I see a lot of affirmative there. That's nice. So that's method 1. If you like method 1, just do it that way, and you could ignore me for the next minute. I'm going to show the method 2 now. So method 2, of many methods, there's lots of ways to do this. I'll just put it up here. Method 2. I'm going to write words here because this one here, I didn't write any words. Find the change, find the increase. Let's write words here. Find the increase, then add to original. So that's kind of like the method in a nutshell. And then over here, method 2 is going to be, whoops. Method 2 will be find the overall factor. So to find the overall factor, what you do is you do 100%. You do 100% plus 24%, which is 124%, or 1.24. So you find the overall factor first, and then multiply that by the original amount. You do 1.24 times 250 kilopascal. And I'm not going to cheat. I'm doing it on my calculator here. I mean, I'm not going to just say that it's 310 without actually demonstrating it on by myself. And you should convince yourself as well. Now you have two methods at your disposal. Kind of like Star Wars. We have the light side and the dark side. Okay, who's with the Jedi? Who's the blue here? Who's blue and who's red? Who's blue? Who's red? We got a blue and a red. Blue and a red. Okay. So okay. So Nicholas is kind of like Darth Vader. So Nicholas is the Darth Vader of the class. If you like Star Wars, at least. Nicholas is both good and evil. Not that red is evil or blue is evil. I'm just making that up. Anyway, it doesn't matter which one you like, as long as you do it correctly. But if you can understand it both ways, then it's all good. And I'll tell you this, if you ask me which one I like better, usually I like 2 better when the numbers are not nice. But if the numbers are easy, or if I'm being forced to do it in my head, like sometimes I like to force myself to do mental math. So if I have numbers and I have to do it in my head, I find it's easier to just do to do it method 1 way, because it's just a smaller computation, and adding numbers in my head is easier than multiplying bigger numbers in my head. That's just personal preference. So anyway, I thought with that example that you can identify at least method 1 and method 2 for percent increase. So you know what's coming up now. I'm going to hit the shift button here. Otherwise, there we go. We're going to do the same thing with decrease. We're going to apply the exact same skill here to the next question. So if you don't mind, I'm just going to copy and paste some text here. So we have here decrease 90 kilograms. Just excuse me for about 20 seconds. Okay, we're good to go now. So first step is to find, if we're doing method 1 here, similar to before, just find the decrease first, and then take it and add it to the original amount. Sorry, subtract from the original amount. There we go. So the decrease here, you guys are way ahead of me, so just bear with me as I'm catching up to your skills. It's all good. It's all good. I got 16.2. Can someone confirm? Okay, so that's the right answer, Huria. Thank you. Based on my number here, that would make sense. So that's good news. We're going to do here 90 kilograms minus 16.2 kilograms, which is 73.8 kilograms. Again, if you like method 1, and don't look at method 2. Don't even bother. But if you wanna see how method 2 applies, let's see how it goes. So the key thing is here. Notice that I use the number 100%. This is the key to the question. You take 100% always. So let's put that in purple. So you always start with 100%, but this time you're going to do a minus 18 because it's a percent decrease question. So you're going to lose 18%. You can think of it like this. Just bear with me while I do some coloring. Okay. If you look at this over here, what it's saying is that there's 100% as a reference, and you're going more than 100% because you're adding extra. In this case, if I take 100 minus 18, I'm left with 82% or 0.82. So what this is saying is, let me say it differently. If you lose 18% of what you have, how much do you keep? Well, you keep 82% of what you have. So you can think of it as like, this is pessimistic. This is like negative thinking, right? Like you lost 18. Or you can think of it like the other way around and say, oh, okay, I retained or I kept 82% of it. So if you think of it like that, like, kind of like positively, like in a good vibes kind of way, then it actually helps a little bit better. So 0.82 times, let's see here, 90 kilograms is 73.8 kilograms. Anyway, I hope that you got a better understanding of percent increase and decrease with these two examples. The rest of the questions that are going to follow, whatever we cover with from this piece here now, really just amount to doing the same thing over and over again, whether it's increasing or decreasing. So I just picked one more question here, which is another decrease question. So the word depreciate just means it's like a loss, or you lose, or you decrease by, okay? My aim is that you are able to my aim is that you should use the calculator and the technology because you have it available to you in class. But hopefully, when I'm doing little things here and there to help you, it's just to help you get confidence that you could do it in your head. So the ideal situation would be for you to always either, just in terms of benefiting your math skills and in the future, I mean, it's always about, in my opinion, try to guess the answer in your head, whether it's exact or estimate, the best you can, and then do it with the technology. This way that you are not as reliant on the technology to convince you that the answer is correct. So it's just more about building your confidence. So in this case, it's oh my gosh, you got all the answers already. I should just I'm gonna use method one here if that's okay. Okay, let's use method one here. We'll do method one. We do 3,300 minus 0.12 times 3,300. What did I do there? You see what I did? I did method one. I did all the blue stuff here, but I just wrote it in one line. So if I do that here, 3,300. Oh, Huria is going on tilt here. Look at that, 2904. And I'll just take down your answer for method two. Since it's there, you know what? I'll never say no to a gift. So thank you very much for the gift. 100% minus 12% is definitely 88% or 0.88. And then we'll do 3,300. Whoops. Yes, I can type 3,300 times 0.88, which is what that answer was earlier. Okay. Anyway, you got two approaches. Pick which one you like, stick to it, and hopefully you feel good about it. We're gonna take a step back here, and we're gonna do a crusty little question, which is number 7. You see it says harder, okay? So whenever you see a question that says harder in a book, in these booklets at least, then when it comes to a test, you can think of it as kind of like the challenge questions or the tougher ones. So I will discuss the test a little bit on Friday. So if for those of you that don't know, there is a test next Wednesday, and all the information about the test, whatever you need to know about the test, I have posted it on Blackboard. I've posted it in two places, under the announcements and also under a tab called tests. So as you have your assignments, where you do all your assignments, there's another tab called tests. So if you look in that tab, there's a file, one page, and it just tells you about the test. It tells you what's on the test. It gives you some hints. So I'm going to talk about that on Friday. But for today, I want to finish this question, try a little bit of the next stuff, and then have some time to answer some questions that students had about the assignment. So this question is a little bit crusty. It says, what percent decrease would counterbalance an increase of 66%? So you could do this different ways. You could start, I'll just do it. You don't need to have the $100 here, but I'm just going to do that for example, okay? Let's just do this as an example. For example, let's say we start with, but you don't need to do this. You don't need to have the $100. I'm just showing you this way because it's safe. Let's say we start with $100. So if we increase by 66%, how much money do we have? I'll use method 2 here. I'm going to do 100 times 1.66, which is $166. So now we want to, the question starts here. What percent decrease would get you back to $100? So that's really what the question's asking. So let's see how we do that. Let's see how we do that. We're going to do I'll show you the way that I would solve this. I would do 100 times something equals, 166 times something equals 100. Before I finish this one, anybody want to guess the answer? What do you think the answer is? I've silenced the audience a little bit. 1/3. I don't remember the answer. I'm not going to cheat. So let's see what it is. It's probably something weird anyway. If you solve for this question mark, we end up with 100 divided by 166, which is 0.602. So that's 60. That's 0.602. So I'm gonna just say it over here. We're kind of relying on method 2 here. Method 2 is helpful here. What we're gonna say is that 166 times 0.602 gets you back to $1. Gets it back to $100. So what that means is that if we talk about method 2 as 100% minus question mark equals 60.2%. So that question mark is going to be 39.8%. That's kind of a little bit nasty. I know it's a little bit nasty, but that's really what it comes down to. I'm going to show you a different way of solving it as well. I put my name here anyway. The way that I would do it, like the fast way, my faster way, is as follows. We know that we increasing by 66% means times 1.66. Decreasing by something means multiply by 0 point something. So what I'm going to say is the following. I'm going to say that together, multiplying by both. So the bottom line is I would do 1.66 times something equals 1. And then to solve for that question mark, I would do 1 divided by 1.66, which is equal to 0. Whatever I said earlier, 602. Just double checking that. And then I would work that backwards from the percent decrease. So 0.602 is equivalent to 100% minus 39.8%. Maybe the word faster is not here. Let's get rid of the word faster. Thank you. Thank you, Nicholas. The word faster is probably less appropriate. What I meant to say is that my way, which does not involve which does not involve assuming $100. That's what I'm trying to say there. For those of you that are like, why am I doing this? I'm just trying to show you a way where you don't have to make any unnecessary assumptions like there's $100 to start with or such. So I think I was hoping to cover one more question today. Sorry, one more section today, but it looks like we're nearing the end of the class. So maybe it's a good opportunity here to stop, and then on Friday I can do the last two pieces. That should be okay. How I got 1.66? The 1.66 because the question says increasing by 66%. Remember I talked about method 1 and method 2? Do you guys remember method 1 and method 2? Yeah, it's right there. See? So it's from method 2. But I called method 2 earlier. Meaning that it's 100% plus 66% or 166%. So that's how I got that, okay? I'm glad to be of service on that one. That's why this question's harder. Like, that's not a joke. This question's not a joke. This is weird. Using method 1 here is you're somewhat vulnerable to getting confused because you can't. It's very hard to kind of patch it together to make it work. It is possible, but it's frustrating as well. I think that's enough for today. I know that I like to finish class at 10:50, which is the appropriate time as per the policy for our department. But some people have questions about the assignment, so I'll post this up on Blackboard and we'll continue the booklet on Friday. So what I want to do now for the remaining time is if people have any questions about the assignment, you're free to ask some questions, or you can depart, and we'll see you on Friday. So anyway, I'll stick around for some questions if anybody has questions.